Hello and welcome. In this session 5.5, we will cover the tests on rock joints to determine joint shear strength and the normal stiffness. You have learned about joint normal stiffness and the joint shear strength, particularly on joint shear strength criteria. This session is on testing methods. Joint shear strength test is perhaps the most important test on rock joints. Standard or suggested test method are given by the International Society for Rock Mechanics. You can find the original ISIM suggested method produced in 1974 and the revised and updated version after 40 years in 2013. Joint direct shear tests are conducted using the direct shear machine. The figure on the right shows a typical shear test machine. The shear test machine should be capable to apply, measure, and control normal load and the shear load. The test specimen is assembled in a direct shear box. The shear box has up and the lower halves to fix the up and the lower half of the joint. While one half is sliding against the other half, it brings the joint to shear along the joint plane. The shear test system should have measuring devices for normal and the shear displacements. We will elaborate the load and displacement measurement in the next slide. Measurements of load and displacements are recorded by data acquisition system. Some advanced direct shear machine has servo-controlled systems for both normal load and the shear load. Common shear test is done by applying a constant normal load and then shear the joint to measure the changes of shear stress, shear displacement, and the normal displacement. Therefore, the shear machine should allow for load and displacement measurements and the control. Commonly, machine should be able to control normal load and the shear displacement. For example, control the normal load at a constant and the shear in the joint at a constant velocity. Normal and the shear displacements are typically measured by LVDTs. There should be at least 2 LVDTs for normal displacements and 2 LVDTs for shear displacements. Before we start the test, we need to prepare the specimen and the shear box assembly. The specimen preparation procedure explained here are for typical natural joints selected from core samples. If the sample is a block containing joint, then the block needs to be cut to the size and then can be fit into the shear box. First, select the rock cores or blocks containing the joint to be tested. The joint selected should be representative. Cut the core or blocks with the base to be parallel to the joint plane and the thickness to be smaller than the box. Make sure the upper and the lower half of the joint's specimen can be fitted into the upper and the lower shear box. While cutting, the joint should be protected from damage. For example, by wrapping up by tapes to preventing joint movement during cutting. The next step is to fix the joint specimen in the shear box. This is done by mounting the upper and the lower halves of the joint specimen into the upper and the lower shear box by encapsulating materials such as cement, as illustrated in the diagram below. While fixing with cement, make sure the joint plane is laid horizontally along the shear direction. The upper and the lower halves must be in coinciding position. The joint plane should be higher than the level of the shear box, so there is sufficient gap for joint closure during the loading and the shearing. That is, during the test, the upper and the lower shear box should not be in contact. To start the test, first, make sure you measure and record the specimen dimensions, joint surface profiles on both sides of joints, and take note on the general conditions of the joint, such as coating, stains, and the weathering signs. Then you place the shear box with rock joint specimen in the shear machine and attach the normal load and the shear load pistons and the normal and the shear displacement measurements. Now you can apply normal load to the prescribed normal stress for the test. The normal stress should be applied continuously at a rate of 0.01 MPa per second. This is to achieve the desired normal stress in 1 to 5 minutes. After the prescribed normal stress is achieved, maintain the normal load at constant. While applying the normal stress, measure and record the normal displacements and normal stress during normal loading at the 1 Hz frequency. After setting the normal load at constant, apply the shear load to move the upper half of the shear box, or the lower half depending on the shear box configuration, to slide along the joint plane, while the other half of the shear box is stationary. During the shearing, shear displacement should be kept at a velocity of 0.1 to 0.2 millimeter per minute. During shearing, normal load should be maintained at a constant at 2% variation of the prescribed value. Shear load, normal load, shear and the normal displacements are measured and recorded, again at 1 Hz frequency. Normally, we will stop the shear test when the shear displacements reaches 5 to 10% of the joint length. The measurements on normal load and normal displacement can be analyzed to derive the normal stiffness. We can plot normal load, normal displacement curve from those measurements taken during the normal loading stage before shearing. A typical normal load, normal displacement curve is shown on the right. It is typically a curve, curving upwards. Stiffness is defined as the change of displacement by change of load. Joint normal stiffness is therefore the tangent of the joint normal load and normal displacement curve. Because that the normal load, normal displacement curve is a curve, therefore the tangent is different at the different locations on the curve. In fact, you obtain relatively low normal stiffness at a low normal load and a much higher stiffness at a higher normal load, as shown in the right illustration. In the shear test, the normal load applied may not be high, so we will only get normal stiffness within the range of applied normal load. We can learn about joint normal stiffness in section 3.4, and you may want to revisit that session in connection with the analysis on joint normal stiffness. Now let us move to the data analysis for shear strength. We start with plotting the shear displacement, shear stress curve obtained for each shear test. The plot can be done by the computer, which logs and stores the measurements. A typical plot of shear displacement as x-axis and the shear strength as y-axis is shown on the upper right. From the shear displacement shear stress curve, we can straight away get the peak shear strength as the peak of the curve and get the residual shear strength, which is the more or less stable part of the curve at the end of the test. We can also plot shear displacement, normal displacement curve from the measurement. And the typical curve is shown on the lower right. From the curve, we can obtain dilation angle of the joint before peak. You may want to revisit session 3.5 on joint shear strength criteria, where we have discussed joint peak shear strength, residual strength, and the dilation angle in that session. What we have done so far on data analysis is for each shear test at a constant normal stress. We have obtained peak and residual shear strengths. We usually will do a series of shear tests at different normal stresses in order to find the joint shear strength parameter of cohesion and the friction angle. With a series of shear tests at different normal stresses, use the method we just learned on the last slide, we can have a set of results of normal stress, peak shear strength, and residual shear strength. We can plot the normal stress, peak shear strength, and the normal stress, residual shear strength curves, as shown on the right. We can find the various shear strength parameters from those plots, such as the friction angle phi, the residual friction angle phi r to cohesion C and the initial dilation angle I is illustrated on the right diagram. From the curves and the parameters, we can develop the shear strength equations, the linear one, the bilinear equation, or the empirical JRC, JCS model, as covered in session 3.5 on joint shear behavior and the criteria. Test descriptions, data and results are to be presented in the report for joint shear strength test. The report generally will need to include the information listed below. A. Rock and joint sample information, including the logical description, joint type, sampling location depth, sampling date and method, storage history and environment. B. Testing date, description of test machine, sample cutting and preparation, and the shear box encapsulating method and the materials. C. Description of joints, including joint surface condition, joint roughness, and joint matching. Measurements of joint surface profile, at least along 3 alignment on each side of joint, should also be presented. D. Photographs of joint surfaces before and after test. E. Descriptions of joint surface and the sheared off fragments after the test, particularly to note the made shear off asperities. F. Test data on normal load, shear load, normal displacement and the shear displacement, and the computer-generated curves of normal load, normal displacement, shear stress, shear displacement, normal displacement. G. Calculated peak and the residual shear strengths from the curves in E or in F, and the tabulated normal stress, peak and residual shear strengths for all the tests. H. Plotted curves of normal stress with peak and residual shear strengths, and the calculated values of peak friction angle phi plus I at a lower normal stress, cohesion and the friction angle at a higher normal stress, as well as residual friction angle phi r. We mentioned about normal stiffness earlier in the test procedure. Sometimes normal stiffness determination is required, together with the joint shear strength determination. If normal stiffness is required to be reported, the report should also present the normal load, normal displacement data, and the curves generated from recorded measurements during normal loading. The values of normal stiffness determined from the curves should be tabulated to present the normal stiffness at a specific normal stress level. With a number of joint specimens, mean value and the range of values can also be calculated and presented. The ISRM suggested method also mentioned about shear strength tests with constant normal stiffness. This is to simulate the block sliding with normal displacement confined. Joint shear tests with constant normal stiffness can be performed by fixing the normal displacement at a constant. That is, no normal displacement is allowed during shearing. This can be achieved by a stiff normal loading machine or by servo control of normal loading. In such test, normal stress is no longer constant. It changes with normal dilation. Test description and data analysis can be found in the 2013 ISIM suggested method given at the beginning of this session. You can also find literatures on shear behavior under constant normal stiffness or normal confinement. I am ending the session here on joint direct shear test. And goodbye, and see you at the next session.